Hello guys, welcome back to the channel. Today we're going to solve this Leetcode question, which is remove nth node from the end of the list. So it is a medium question, and in this question we are basically given the head of a linked list, and we need to remove the nth node from the end of the list and return its head. So we're basically given this linked list, and what we need to do is we're also given an n value. So we need to return the nth node from the end. So if you look at this example, in this example, we're given 5 nodes, and from these 5 nodes, we need to return the second most node from the end from the linked list. So which is the second most element? This 4, right? So we need to remove this, and we need to remove return this list as the answer. Let's suppose we have only one element, and we're removing the first element from the end. So we basically have only one element, and we're removing the first node from the end, so it is the element, so we'll be left with nothing, right? So and we're having something like 1 2. We need to return the we need to remove the first node from the end, which is we need to remove 2, so we'll be returning 1, right? So if you look at the constraints, the maximum number of nodes in the list is sj. I don't know what the size, I guess the maximum size can be at most 30 nodes. So we can also use 2 for loops or 3 or 4, but we can do it in order of n solution. And then we don't need to worry about node values, right? And the n can be from 1 to the size of the linked list. So after looking this question, the most basic approach that comes to our mind is that what I'll do is I'll just find out the length of the entire linked list, and what I'll do is iterate iterate length minus n minus 1 times. Why am I iterating length minus I minus 1 n minus 1 times means, suppose let's suppose my length is 5. The length of the linked list is 5. This is not given. We need to calculate it. We need to find out. Well, let's say they have given n as 1. So we need to remove this node, right? So what I'll do is initially I'll start from here. So I'll go to here. I'll go to here and I'll go to here, since this is my node that I want to remove, right? So when I'm here, I cannot remove this node because it has a next pointer, but it does not have a previous pointer, right? So what we need to do is we should not stay on top of the node that we want to remove. We need to stay one step behind to the node which we I'm sorry, we need to remove this node, right? To remove the last node. So I'll go here and I'll go here. When I'm at this node, I cannot remove this node directly since I cannot point to backwards, right? So what I'll do is, as I have already said, we need to be one step behind the node that we want to remove. So we need to stop here in order to remove this node. So what I'll do is I'll make 4 dot next equals to 5 dot next, which will become null, right? So this link will be broken and this will be pointing to this one. So since pi does not have any reference, it will be not in the linked list, right? So let's look at another example. So let's say we need to remove this node when n equals to 2. When we want to remove this node, so when I want to remove this node, I need to stop at this node, right? So I'll start from here. What is my length? My length is 5, right? So I need to make one and only two steps, right? So I need to make 5 minus n minus 1, which is 2. So this is how I got this formula, which is length minus n minus 1 steps. So I'll iterate 1 and 2 times. So I'll be here. So what I'll do is now 3 dot next equals to 4 dot next. So this will point to this one, and this link will be broken. And there is no need to break this link. We can just return like this. So it will be 1, 2, 3, and 5 and null. This node will won't have any reference, right? So this is one of the approach. But what's the time complexity means? In order to in order to find the length, however, first of all, let's see how we can find the length, right? First, we need to identify that in order to solve this. So it will be like this, and this will be pointing to null, right? So how am I going to find out the length means? I'll start from here. While this is my PTR, this is my pointer. While my pointer is not equals to null, I'll keep a counter. I'll keep a count value. Initially, it will be 0. So since my PTR is not equals to null, I'll increase my count. I'll increase my count and I'll move my pointer. My pointer will come here and my count will be 1. And again, my pointer is not equals to null, right? So I'll again do the same. So my count will be 2 and my pointer will be here. My count will be 2. And I'll again do the same. I'll again do the same and I'll come here. Then my count will be 4 when I'm here. So I'll move my pointer to here and my count will become 5. The count will become 5. But if you look at this right now, my pointer points to null. When my pointer becomes null, I'll stop and then I'll get the count of the linked list. So this is how we're going to solve this question. So let's look at the code. So initially I need to before that we need to take care of a corner case. A corner case. Let's say our let's take the same example so that it will be very easy for. So let's say our length is 5 and our n is also 5, right? Then what we need to do is we need to remove the fifth node from the end, which is 1, 2, 3, 4, 5. So we need to remove this node, right? So how are we going to remove this node? We cannot have a pointer before this, right? So what we can do is when my length and the nth node from the end which I need to remove, when these both are same, then what I need to do is I'll just return head dot next. So the this node sorry, the head dot next will only have this linked list, and this reference cannot be again this sorry, like we cannot there is no reference to this node again. That's what I'm going to say. Like when we are returning this head dot next, we'll only have the reference to the next nodes. We cannot have the reference to the previous node. So we need to take care of this what they call corner case. So initially I'll take care of the corner case. So for that I need to get the length. What I'll do is get length of the linked list. This node of head, I'll pass the head. Initially, as I have already said, I'll have a counter variable while I'll initialize a pointer variable ptr equals to head while ptr not equals to null. I said I'll increase the count and my ptr will point to the next node. I'll just return the count. We'll get the length by getLength function by passing the head. If my length is equals to n, what I said was we need to return head dot next, right? That's it. And when my n value is not equal to length, then what I need to do is I need to go from 0 to I less than length minus n minus 1 a plus plus. For that I need to have a pointer variable, right, which points to the head. pdr equals to pdr dot next. Now what I'll do is pdr dot next equals to pdr dot next, and I'll just return my head. So if I submit this, it is working fine, but let's look at the time and space complexity right now. The time complexity is, you know, initially we're finding the length of the linked list, right? So it will be order of n plus we're again traversing through the entire list. In the worst case, we'll traverse the entire list, right? Again, so it will be order of n plus order of n, and the space complexity is order of 1, since we are not using any extra space. So we're using two passes, right? So we're basically traversing the linked list twice. But in the interview, the interviewer may ask us to optimize the solution, like, can you do it in one pass? Could you do this in one pass? Then we need to optimize the solution. So let's look at how we can do that. Suppose we have. So let's look at the second approach, guys. In this approach, what we're going to do is, suppose we're being asked to remove a node which is thought from the end, right? So we need to remove 1, 2, 3. We need to remove this node, right? So what we are going to do is we'll play slightly, a tricky approach. It's not a tricky, it's very easy to understand. What I'll do is I'll just move, I'll just have a pointer initially at here. I'll have a pointer here at the start, at the beginning. What I'll do is now I'll move this pointer 3 steps. Let's say this pointer is end. I'll move this pointer 3 steps, which is 1, 2, and 3. So this pointer will move to here, right? So this pointer will be on this node. Now what I'll do is I'll start a new pointer from here. This is start, this is end. Now I will move both the pointers one step ahead, one step at a time, till my end reaches this pointer. Sorry, till, till my end pointer reaches the last node. When my end pointer reaches the last node, my start pointer is just before the node that we want to remove. Let's see how this works. So initially our configuration will be like this. Then what I'll do is I'll move both these one step ahead. So this will be here, start will be here, and my end will be on this node. Again I'll do the same until my end reaches this node. So my start will be here and my end will be here. I'll again do the same thing. My start will be here and my end will be here. So when my end reaches the last node, then my start is just before the node that we want to remove. This is the node that we are going to remove, right? Which is third from the end. Now what I'll do is I'll make start dot next equals to start dot next, right? So then this reference will be removed and this node will have no reference. So this will be removed from the linked list. So this is the trick that we are going to follow. But we need to take care of one more edge case, which is when n equals to the length of the linked list, right? So let's say our n is 7 at this point. Now what will happen when we move our end initially? Initially I'll move my end steps, right? So initially my end will be here. I will move it 7 steps. 1, 2, 3, 4, 5, 6, 7. Initially my end will point to the null, right? Then I'll start my start here and my end will be here, right? So then I'll remove 2, which is not correct. So what we're going to do is when n reaches null, we'll just return start dot next. N equals to 7 means we need to remove the seventh element from the end, which is this. So what I'll do is n when n is 7, 7 in the sense when n is the length of the linked list, when n is equals to the length of the linked list, then my n reaches the null. When my n reaches null, I'll just return start dot next. Then this list will be returned so that this element will be removed. Let's see how we are going to code this solution. We don't know, we don't need this extra pass. What I'll do is initially I'll have a list node end equals to head which points to the head. Now my end moves n steps, end equals to end dot next. As I have already said, when end is equals to null, this means we need to remove the first node. So I remove the first node and I'm returning the next from next. Now, and what I'm going to do is now we'll start the start pointer start equals to head which points to the head. Now what I'll do is while my end dot next node, node equals to null, which means it stops when we reach the last node, right? I will move my end one step. I'll move my start one step. Now what I'll do is start dot next equals to start dot next dot next. I'll just return the head. That's it. If I submit this, it works fine. So this is the most optimal approach. I'm sorry. So let's see what's the time complexity. Since we are traversing the entire linked list only once, our time complexity is order of n, and space complexity is, as you have already guessed, is order of 1 since we are not using any extra space, right? So that's it guys for this video. If you find the video helpful, just give it a thumbs up.